Ever wish you could, like, just tell an AI what to do?
Mm-hmm.
Even if it was something totally new and it would just, get it.
Yeah.
That's the dream of zero-shot learning.
Right.
And we're diving into a paper today that claims it's closer than ever.
It's a bold claim.
Yeah.
It is a bold claim. But the research is seriously cool.
Right.
We're talking about getting AI to understand and perform tasks they haven't been specifically trained on. Like, acing a pop quiz on a subject they've never even seen before.
Okay, that's a pretty high bar.
Yeah.
We know, like, large language models, these LLMs everyone's talking about,
Right.
they're good at certain things, like GPT-3.
GPT-3, yeah.
With its text generation translation skills.
Yeah.
But how do they handle something they've never encountered?
So you're talking about the difference between few-shot learning, where you give an LLM a few examples and it kind of catches on, versus true zero-shot learning,
right.
which is, can you do it with no examples whatsoever?
Right, so it's like the difference between following a recipe.
Yeah.
And just, like, whipping something up with whatever's in your pantry.
Right. Yeah, like, my cooking skills.
More few-shot reliant. Yeah. But this paper's focuses on the models that can go off script.
Yes.
Yeah. What makes them tick?
So the researchers used a task called natural language inference, NLI, to test this. And you can imagine, like, giving the AI 2 sentences and asking it, does one logically lead to the other?
Oh.
And that requires, like, real understanding, not just, like, pattern recognition.
So more than just knowing words.
Right.
It's got to grasp the meaning behind them.
Exactly.
Tricky.
Yeah.
Did any of the models manage to pull it off?
So they found that even GPT-3, as powerful as it is, struggles with zero-shot NLI. It's not that it's incapable, it's just that it seems like it needs those instructions phrased in a way that it's been trained to process.
Okay.
It's...
So it's like you wouldn't expect someone who only speaks French to understand directions given in Japanese.
Right, exactly. It's not that they're, incapable of understanding those directions. They just don't speak that language.
Okay, so it's not about the AI being dumb. It's more about us learning to speak its language.
Yeah, exactly.
Okay, but that leads to the big question.
Yeah.
How do we unlock that potential? How do we bridge that communication gap?
Right, and that's where things get really interesting.
Okay.
Enter FLAN, Finetuned Language Net.
Okay.
It's a 137 billion parameter LLM, so smaller than GPT-3.
Okay.
But it has a secret weapon, instruction tuning.
All right, I'm hooked. Spill the tea on this instruction tuning thing. What's the magic ingredient?
Okay, so instead of training on just one specific task, imagine giving FLAN a crash course in understanding instructions themselves.
Okay.
Okay, so we're talking about a library of over 60 language datasets covering 12 diverse task types.
Wow.
It's like giving it a PhD in understanding language.
Whoa, hold on. They basically threw the whole library at it.
They did.
What did these instructions actually look like?
So they were formatted as natural language, just like you talk to a person.
Okay.
So for example, for translation, it might be translate "how are you" into Chinese.
Okay.
For sentiment analysis,
Wow.
Is the sentiment of this movie review positive or negative?
So it's not just crunching data.
Right.
It's learning to decode what we mean when we ask it to do something.
Yes.
That's wild. But did it actually work?
It did. It did. But we have to make sure FLAN wasn't just memorizing answers from its training. Right. The researchers had to get creative to test its true zero-shot skills.
Okay, so how do you make sure an AI isn't just a good memorizer?
Right.
Pop quiz time.
Essentially, yes.
Okay.
They grouped those data sets into clusters based on task type, like translation, sentiment analysis, you name it. Then they trained FLAN on some clusters while keeping others completely hidden.
So it's like studying for some subjects but not others and seeing if you can still ace the surprise exam.
Exactly. And the results, FLAN didn't just pass. It aced the test.
What?
Often outscoring even GPT-3 in these zero-shot scenarios.
Wait, hold up. You're saying this smaller model, FLAN, with its instruction tuning, beat out the bigger model, GPT-3, on tasks it had never seen.
Correct.
That's a game changer.
It is. It really throws a wrench in the idea that bigger is always better when it comes to these models.
Right.
You know, FLAN's secret sauce is its ability to apply its knowledge broadly, thanks to those instructions.
So where did FLAN really shine?
Yeah.
What tasks were its A+ subjects?
Remember those tricky NLI tasks?
Yeah.
Figuring out if one sentence logically follows from another?
Yeah.
FLAN rocked those.
Okay.
Even beating out GPT-3's scores on some.
Wow.
Even when GPT-3 was given a few examples beforehand.
No way.
Yeah.
It's like it developed this knack for understanding the nuances of language and reasoning.
Right.
All thanks to being told how to think instead of just what to think.
Exactly, yeah, and it went beyond that.
Okay.
FLAN also killed it in reading comprehension, answering questions from a given text, and even in closed-book question answering, where it had to rely solely on its existing knowledge.
Wow. Talk about a well-rounded student.
I know.
But every model has its limits.
Sure.
Was there anything FLAN stumbled on?
That's a great question.
Yeah.
As impressive as FLAN is, it's not a universal champion.
Okay.
It actually performed less well on tasks that were essentially just about predicting the next word.
Okay.
Like finishing a sentence?
That makes sense, though. If it's just about predicting the next word, the instruction element might not be as helpful.
Right.
Right.
And what's even cooler than just the results themselves is understanding why this instruction tuning worked so well.
Okay.
The researchers did a deep dive into FLAN's success, like detectives searching for clues.
Okay, so what were the secrets to FLAN's success? What did these AI detectives uncover?
So they found that 3 key factors contributed to FLAN's zero-shot prowess.
Okay.
First, the diversity of instruction tuning clusters was crucial.
Okay.
Remember those different task types?
Yeah.
Turns out, the more of those FLAN was trained on, the better it performed on unseen tasks.
So it's like the saying goes, variety is the spice of AI life.
Yes. Yeah.
The more diverse the training, the better it can handle those curveball tasks.
Exactly. And second, they found that size does matter.
Okay.
At least to a point.
Okay.
Instruction tuning really only took off with those larger models, 8 billion parameters and up.
So those smaller models, they were trying their best, but just didn't have the brain space to absorb all those instructions.
Yeah, it seems that way. It's like trying to cram for a final exam with a brain full of cotton candy. You need the capacity for all that knowledge.
Right.
And finally, here's the real kicker.
Okay.
Those instructions themselves were the magic ingredient. Like, just mixing the data sets without clear instructions actually make things worse.
So it's not just about showing up for class. It's about paying attention to the teacher, those instructions to really ace the test.
You got it. FLAN thrives on learning how to follow instructions, not just memorizing information. But the researchers didn't stop there.
Okay.
They also explored whether a little cheating could boost performance even further.
Cheating. Wait, are we talking about giving FLAN the answers?
Not exactly. Think of it more like giving it a few hints. They experimented with few-shot instruction tuning, feeding FLAN a handful of examples at the last minute.
Okay.
Alongside the instructions.
Ah, so like giving it a cheat sheet with a few formulas before the math test.
Yeah.
Did that help?
You bet. Those few-shot examples significantly boosted FLAN's performance, especially on tasks that required more complex outputs like translation or those tough closed-book question-answering challenges.
That makes a lot of sense. Even we humans usually perform better when we have a few examples to work with, right?
Absolutely. But what's really exciting is how instruction tuning opens the door to even more advanced techniques.
Okay.
Like something called prompt tuning.
Okay. We've been throwing around instructions and prompts this whole time. All right. What's the difference, and what's so special about this prompt tuning?
Okay, so think of it this way.
Yeah.
An instruction is the overall task you want the model to do.
Okay.
Like translate a sentence.
Right.
A prompt is the specific input you give it, like the actual sentence to be translated.
Got it. So the instruction sets the stage, and the prompt is like the cue for the performance.
Exactly. Now with prompt tuning, instead of just using words as prompts, you're getting into the world of optimizing continuous prompts.
Okay.
These are like special codes the model understands, allowing for incredibly fine-tuned control over its output.
So it's like upgrading from a basic set of stage directions to a high-tech control panel with a million sliders for every aspect of the performance.
That's a great analogy. And guess what? The researchers found that instruction tuning made FLAN much more receptive to this prompt tuning, leading to even better performance on those really challenging tasks.
This is blowing my mind. We've got instruction tuning, few-shot learning, prompt tuning. It's like we're assembling a toolkit for building superpowered AI.
That's a great way to put it. But remember, this research isn't just about one model or one technique.
Right.
It's about a fundamental shift in how we think about AI development.
So what does this all mean? What's the big takeaway for our listener?
For a long time, we've been building specialized AI.
Right.
Each model, a master of one task, but lost outside its lane.
Right.
FLAN shows us a future of generalist models.
Okay.
Capable of handling a variety of tasks based on simple instructions.
Right.
Almost like a human apprentice learning their craft.
That's an incredible thought. We're moving from narrow AI to something much broader and more adaptable. It really begs the question, if you can teach AI to follow instructions this way, what other human-like abilities are within reach?
That's the question, isn't it?
Yeah.
And that's what makes this field so incredibly exciting.
Absolutely. It seems the future of AI is full of surprises, and on that note, we'll leave you to ponder the possibilities. This has been a fascinating deep dive. Thanks for joining us.